And now I would like to welcome to our virtual stage Errico Armandillo, who has been working in the field of optics for over 45 years. From 1985 to 2014, he was employed by European Space Agency, where he was also head of optoelectronics section, dealing with the use of optoelectronics in space. The topic of his presentation is Advance in Photonics Technologies for Observations from Space. Please.
Very much for your introduction, and thank you for inviting me to this event. And I would like to greet everybody from what I'm saying here in Portugal. I've another event which was planned before, and unfortunately I've not been able to attend online. So in my talk, I will try to provide an overview of why we need photonic space. What can we do? What are the technology for space? What are the technology in space? And why photonics is so important in view of the spin-off and the impact which can have on the society and on the industry of our country. And then I will just drop out to the conclusion. First of all, let's define what is photonics. Essentially, photonics is all about all possible combination of light and electronics into sensors. Okay, and as a matter of fact, today we can find photonics almost everywhere on a space satellite, on the instrument, on the sensing, on the component, on the payload, and even on the satellite itself, and on the launcher. So essentially, we can find photonics end-to-end in all space systems. Okay, and why photonics? Because with photonics, we can have new function, better services, better performance than possible before. And as I said, it's very important, photonics that will provide a good European taxpayer return for industry, for social life. Okay, so by photonics generally, my definition involves three major areas. Essentially, it's light generation, light detection, and light processing. This is the generic characterization of photonics. More specifically, by light generation, we mean generation of light, or laser light. So we have laser diode, fiber laser, all kind of LED laser, etc. In light detection, that's covers a wide area of sensor, a sensing technique, spectrometry, radiometry, imagery, which covered all the spectral range from X-ray to far infrared. Then we have also what we call photonic links. Photonic links are gradually superseding hard cable link because they provide much better performance and much lighter, and in terms of overall mass, weight, size, and capability. Then we have the important domain emerging lately with, again, part of photonics, which is quantum technology. The quantum technology, of course, is based very much on single quantum of the light quantum properties. And domain important for application involves the time and frequency transfer, which is so important today for, not only for space, but also for navigation on telecom, our GPS, our mobile phone, our airport traffic control are very much based on time and frequency transfer. It's fundamental. Without a good time and frequency control, we will be in a mess. And quantum technology helps to improve substantially this synchronism and this time accuracy. Of course, that's involved also quantum computing and the transmission of like quanta. So these are all domains which quantum photonics makes possible. Also very important is for, as we mentioned, for the spacecraft satellite health monitoring. This is a relatively new domain the last couple of 10, 20 years, essentially, thanks to photonics through fiber optics. We are able to check the health of the satellite, of the spacecraft structure. We can detect if there are failures due to thermal, to the mechanical stress, and we can then with a high sensitivity, foresee things happening and look how to remedy this. We have seen much failure in space due to this. As a matter of fact, just talking about the spin-off, this fiber sensing is also quite widely applied in some country for bridges, mostly for bridges, to check the state of the fiber of the bridge structure for decay. Unfortunately, not everywhere, but this is the future. And of course, last but not least, is for navigation altitude control. Today, advanced in navigation, precision navigation, and orbit control is very much possible thanks to optics, to photonics. Okay. So photonics today is a key enabling technology in space for astronomy, planetary exploration, a fundamental science mission on one end, and for Earth observation on the other end. So essentially, photonics is fundamental to all space programs. And it's becoming, as a matter of fact, more and more important in view of the commercial application for telecom, of course, for navigation, as I said, and also for space transportation. More and more photonics is being used by newcomers in the space transportation. There are just this conference I'm watching now. There are more and more satellite builders, launcher builders. They are spreading like mushrooms. And photonics is very important to assure good launch capability and fail-proof missions. I'll provide now some example of where we use photonics. And I will start with space science, essentially astronomy. Historically, starting in 2013, where we had, Europe is launched this Gaia star mapping satellite, which is based on spectrometry. Photometry is very much, photonics payload. LISA Pathfinder very much based on LISA interferometry. It's very much in state of the art of what photonics can do. LISA Pathfinder was an experiment before the real LISA, the laser interferometry for gravitational field, which is still quite ahead to becoming. The Pathfinder to test laser interferometry to get sub-picometer precision has been success thanks to photonics. We see in later 2019, October 2018, a baby column was launched. This baby column did a mission to Mercury. This guy is still flying towards Mercury. We'll get there in 2025 or so. And it's very much less altimetry, which will help getting around the Mercury. We'll help the mapping, we'll help the altimetry, we'll help detecting anomaly on the surfaces. So it's very much photonics. Then in 2019, we have seen TIOPS, which is a space science, what we call S mission at ESA for studying exoplanet. Exoplanet are planets Earth-like, which are outside our solar system. And it's very much based on photometry, essentially, light variation due to planet crossing a star. Now we have lately has been launched Solar Orbiter, very much studying the sun from a very close range. And here has been a challenge in terms of photonics due to thermal. I can imagine thermal environment, doing image in spectral analysis as state of the art. And then we got close. Last year, we saw the successful launch of James Webb Telescope. It's advanced spectrometry and which higher resolution, which allowed to go even very far distant to the origin of the universe. When we have this black body, we will see very, very, very far to increase spectral resolution and timing resolution. Evelyn will go to 2023. This is another science mission to probe the dark matter, which has been postulated that we are going to detect this dark matter that seems to be full the space in analogy of the not dark matter. So this is very important to understand what has been happening, to understand our overall system, life on Earth, this universe, whatever. Dark matter, very important. That's again very much optics, high resolution imagery and photometry, photon detection. And then it's coming just approximately. This is a Jupiter moon experiment. We are going to study Jupiter moon, and how we do it. We do again with high resolution camera, with optical radiometry. It's very much photonics. And as I said at the beginning, still 2034 to come, the most fascinating science mission ever conceived by humankind is the as postulated by Einstein, the gravitational wave. We know they are there. We're going to measure this huge mission, at least interferometry. We build this space antenna with a 5 million kilometer radius, something amazing. Something, and it's coming. We are working toward that. It's top photonics development. That's what science. We go rapidly into Earth observation, essentially our planet. Yeah. So GOCE, which is Earth gravity field, is important, very much important to study Earth gravity anomaly. Was launched 2009, stopped in 2013 as a gradiometry, so I measure the gravity field. And as gravity field is very much irregular on Earth, as we well know, from moon event happening, this big wave on we have in North Europe, the South region of North Europe, due to mass enhancement of the Earth, so enhance the gravity in certain area. So Earth is not a sphere any longer, but it's a bump. Okay, so GOCE will allow to measure this carefully through gradiometry, again photometry application. The SMOS that has been launched in 2009 has been discontinued. Now it's water cycle. Has been using a lot of fiber. It is based on fiber signal distribution. So the first time that in Europe has been used distribution of signal, not electrically, but converted optics and distributed through fiber. That's for noise and performance. Then Swarm launched in 2013. This also is a mission has been launched for using magnetic field and the photonic into magnetometry, accelerometry, and also has a laser reflector from ground, a laser ranging station. And then we go very close into Earth observation application in climatology, in a weather forecast. EOLUS, the project where I've been working myself from day one, was launched 2018, has been, I've also testified by colleagues at this conference time now, has been the most amazing space mission ever launched from everywhere in the world. It is an amazing mission to measure wind. Never wind will be measured. Wind is fundamental weather forecasting, and the weather forecasting is, is very much fundamental for the economy, for navigation, for agriculture, for everything. So thanks to our ADM, EOLUS, we have been improving considerably the weather forecast. EOLUS is still operating, was supposed to operate the 3 years, but it's still operating now, and now there is EOLUS evolution. Coming up. Then, AirCare will be launched the next year. This AirCare is a complementary, is a twin satellite to EOLUS. It will be studying, while EOLUS studied the width, through aerosol and molecular scattering. AirCare will use again LiDAR, like EOLUS, will be studying clouds and aerosol. And this joint mission with the JAXA, the Japanese, which they were providing the rain radar, to complement the cloud information from Merkel LiDAR. So I think I should mention why it's so important to use photonic links. Yeah, why it's so important compared to hard copper? Okay, fundamentally we have a huge bandwidth. Okay, extremely huge bandwidth, so we can transmit as much as we can. We have essentially lossless propagation. This is not like in copper, in the metal there, and this is amazing lossless. We can go anywhere, everywhere, essentially without losses. There is a transparency to any modulation coding format. It is immune to DMI, which is extremely important. It does not induce electromagnetic interference, lightweight, low volume, flexible, and galvanic isolated. So photonic links, fiber optic links are replacing everywhere hard copper because of all these advantages. It is really amazing. And where we see, for example, this fiber optics, where do we see this fiber optics link, a fiber optic sensor? We see this, for example, for monitoring temperature, pressure, strain into structure. Panel is used for the chemical propulsion launcher and satellite, electric propulsion, antenna reflector, and for assembly integration and testing on ground. And as I said, this fiber optic sensor can allow incredible degree of freedom through multiplexing, allow to measure more than one parameter, and they have amazing performance capability in scaling to make many more sensors. The first worldwide demonstration, as a matter of fact, was done in Europe by the European Space Agency, was 2009. Was the first fiber optic sensor on launched on Proba 2. It's a satellite, and this the sensor was developed by MPB Canada. Then second in-orbit demonstration of electric photonic sensing was launched in 2017 by Kaiser Trede, using technology from fast technology in Ireland. So this has been also extremely successful. And last but not least, in terms of application of fiber optics, photonic fiber optics per launcher, we are going to launch at the end of this year Ariane 6. And Ariane 6 really represents the big step forward in terms of capability and health monitoring and application of photonics for launcher, where on monitoring of the structure, monitoring of the engine, leaking of hydrogen, and wireless technology, and optopyro. The Ariane 6 will use for the first time ever optopyro technology. Essentially, the pyro is the detonation of engine, to adjust, okay? And this optopyro is done with the laser pulse. So essentially, rather than burning through a combustion or chemical combustion, just use a short laser pulse and to have this pyro function activated. So you have much better accuracy, much better control. It's much more safe, of course, okay? Now, I think I want to show this wonder of technology and science for which Europe, we are worldwide lead, and I'm very glad for that because I've been working on this project. And before I show some detail of what we have been doing, I would like to, to the conference management there to show this video from Airbus. Please go ahead with the video. Okay, that was Airbus video. Airbus developed the satellite. This is a satellite, and as I said, it's been the most amazing satellite ever built. ESA has invested a lot and many years of development because it has been extremely challenging. And the American has been looking at us with envy for this surprising, amazing satellite, which is still flying after, was supposed to fly 3 years, it's still flying. But what are the benefits? The benefit, as I said, is weather forecasting. The weather forecasting models are very much limited by knowledge of wind. So far, we have not been able to measure wind accurately. But we've been measuring wind only by looking cloud top, or by launching a balloon and see how they move with the wind. But this is not real wind. Real wind, we need to have global wind knowledge throughout the globe, from 0 kilometers to 30 kilometers. I just want to show you a twilight for the capability for improving weather forecasting. This image was relatively a couple of weeks after the launch. Already we could see, you could see this blue and red line, this blue and red shade do represent a wind velocity. Darker is higher speed, lighter is lower speed. Blue color correspond to the two direction. So this represent a presence of what we call a polar vortex, wind in the North Pole, and it's the wind inversion between clockwise and anti-clockwise wind direction. This something, the first time has been observed, this polar vortex, which whose effect we know very well. They are responsible for this very cold weather blast in the northern hemisphere. It happened mostly over Canada, US, but also sometime in Europe is happening because this polar vortex, which are clash within the low pressure zone on the pole, North Pole, from a low pressure zone from the Atlantic, from down below, they lead to a clashing, and they drop down at lower altitude, the very cold air from the North Pole. First time we have seen it, and we have been fascinated because we can study them and we can predict them. We can predict what's happening. As a matter of fact, this they've been used to predict in 2016, there were some cold blast weather in Canada, New York area, and this, we will be able to predict these 10, 12. The other thing also I would see what we're able to do is we're able to also to detect, foresee a hurricane. We can perceive what's happening, and we can anticipate formation of hurricane into into Atlantic, into Pacific. So we can have early alert with the major, the major impact on social, because we can advance very much. We can see when this big tornado or very big hurricane are started developing. How? By looking at this wind, studying this wind, routing the wind, what's happening to the wind. And at the moment, these wind data are being used by all weather forecasting stations around the world. And we have seen improving a dramatic accuracy in the weather forecasting, and also extension on the range of accuracy. I think with this, I'm going to conclude by recapitulating that photonics is very important for telecom, for remote sensing, for navigation, for remote transportation. As we have seen it, it's extremely important. It goes everywhere. It goes everywhere. And it's very important. European industry is leading into this area, and certainly there is a lot of heritage in Latvia. Also, there are Latvian companies working very much with this photonics, and can bring major impact to the country, to Europe, and to human. And let me conclude saying that I see that the future is full of light technology in space. Now with this, I'd like to conclude. Thank you for your attention. And if you have a question, please.
Applause, please. Thank you. Thank you very much, Errico. Your experience is really amazing. And unfortunately, we have to stick on time, but maybe we have time for one question. There is some question from the audience. So I will ask, actually, we are finishing our space stage with you. So may you say a wish to the newcomers to the space industry, please?
Yeah, I think, I would like, I mean, I've been, I'll say 50 years into space now almost. The space is a fascinating technology. It's very challenging. It gets like, I'm retired, I'm still working because I love it. It gets into the bloodstream in you. And it's so challenging because you have always challenging engineering, but also challenging scientific issues to solve all the time. We have seen mission past and mission future, all the challenge we have to go through, and we see the benefit. We see the benefit, in understanding our system, understanding life on Earth, understanding where we come from, improving communication, improving transportation, improving forecasting capability, and improving better where we can have agriculture, what's happening with the flood, what's happening with the fire. We can, thanks to space and thanks to photonics, we can have a better life. So I very much, solicit young engineers from Latvia, RTU in particular, to really join, to do their PhD, doctorate, stage this domain, because, it's a challenging, and they will never be disappointed. I mean, I've been working, I'm retired, I'm still enjoying it like my first day, and I have so many challenging projects still ahead of me. So I wish all of you, the same enthusiasm that I'm having through the space sector.
Thank you very much. And maybe see you in Latvia next time.
Yeah, I'll be coming the other month to Latvia, see my friends in Eventech, yeah? And maybe next year, I hope I will be in person, yeah, settled.
You're really welcomed.
Thank you very much.